Okay, so today let's go ahead and take a look at the use of the law of sines. And let's take a look at what the law of sines is and a couple examples of how we might go about using it to find pieces of a triangle. Now remember, if we had right triangles, the Pythagorean theorem and right triangle trig angle of a right triangle. But if you don't have a right triangle, then those concepts do not work or do not apply to non-right triangles. So we have just any old triangle here, not a right triangle. And the law of sines is one of your laws. We have law of sines and law of cosines, but law of sines is a little bit easier, so we'll start with that. And the one thing you want to remember with the law of sines is sine A over A, where angle A and the side opposite is the little a. So you want to keep the angles as the capital A's, and the sides opposite them, the lowercase of the same letter. So keep that in mind too. So I thought I would highlight it. Remember, this angle opens up to this opposite side here. So keep that in mind. But as long as you know that, all you really need to do is set up a proportion, because these are really just fractions equal to each other, which are proportions. Now, in a proportion, you need 3 out of the 4 pieces in order to solve that. You cannot set up 2 unknowns. So you have to be very careful when you set up. So what we look for in a problem is to be able to set up the proportion where we have 3 out of the 4, and we can solve for the missing piece. So right here we're looking for angle A, which is X, or sine A. We probably use the sine A for, you could say sine X, but it's angle A. Either way you want it to. But what we want to do is, we're going to look for angle A, and it's missing, so we're definitely going to have a sine A over what? Its opposite side, which is 30. Let me move that up a little bit. And now, what other 2 do we have? Well, we don't have C, and we don't have little c. So we don't have angle C, and we don't have side C. But we do have B, and its opposite side. So we would say sine 65. We wouldn't say sine B. We know what B is. 65. And we're going to put that over the 28. Now, as long as you can set that up where you have one unknown and the other 3 knowns, even though sine 65, you don't know what it is, but the calculator does, so it's really not an unknown. So there you have it. Just cross multiply. And in this case, really, to get this alone, we're not really going to cross multiply. In this case, we would just multiply both sides by 30. And put that whole side in the equation. So that's a little bit easier. So sine A, and let me show you that in the calculator. If you have a calculator by mine, you need to be in degree mode. You make a fraction. I'm trying to show this to you so you can see it. I don't know if it's showing up or not. Yeah, make a fraction. And just say 30 sine 65 and over 28. So your answer is 0.97. Now that doesn't make any sense to you right now, but let's just write that down to show you where we're at. Now, basically what you're asking here is what angle has a sine with the ratio of 0.971. So what I would want to do here is take the inverse, sine inverse of this. So, because you're asking what angle has that in this equation right here. So what I would do is I would put shift sine for sine inverse, and then I put the answer. So you just push the answer button here, and it'll put in your previous answer. And hit enter. And you get 76.2, roughly, rounded off to approximately 76.2. At this point, you have to wonder if this makes sense or not. And it should, because a 60-60-60 triangle would be all sides would be equal. This is 28 and 38, so these are kind of close. So the angles should be kind of close. So it does make sense. So 76.2 degrees. Now, here's where we need to do a little estimation for this next one. We can also use the law of sines to find a side. And let's go back up to the angle here, or the triangle, and put 76.2 in there for that measurement, since we just found it. It's a little bit rounded off. But now what we want to do is find AB, which is really little c, isn't it? And the problem is we can't put c, the sine of c, over c, because we don't know what that angle is. But we can figure it out since we have two angles. And all three angles must add up to 180, if you remember that. So if you take 180, you subtract the 76.2 and subtract the 65, you should get angle C. If you remember the angle sum formula for triangles, that's basically all three added up to 180. So we do have to use some of the old concepts that we've learned in past courses for this concept. So 76.2 minus 65, and we get 38.8. All right, so we've got 38.8 for this angle right here. And now we can set up our ratios with this. And this doesn't matter which two, but I would shy away from using one that you solved yourself. You'd be better off setting up with the given. In case you made an error up here, you don't want another error to come out of the second problem. So I would definitely try not to use anything you worked with and try to use the given information as much as you can. So I'm going to do sine 38 over C equals sine 65 over 28. Here you need to cross multiply. 28 sine 38 equals C sine 65. Divide both sides by sine 65 in order to get that variable alone. Sine 65 will equal C. In this case, notice you're not taking a sine or a cosine. There's no sign here. So once you punch this into the calculator, this will be your answer. So we'll just go ahead and punch that in. Again, it's nice to be able to make a fraction. The TI Inspires can do it too. 28, just make sure you're in degree mode. Sine 38. And divided by sine 65. And we're not going to sign inverse this. Like I said, once you enter that in, that will be your answer. So it's C is equal to 19.0. I said 19.02 units is equal to C. So there's your final answer. So there you have it. I hope that helps out. And if you have any questions, feel free to post them in the comments below. And thanks for watching.